We're using a liquid to join two pieces of aluminium together. This liquid is an adhesive. Gloves are worn because this particular adhesive is dangerous if it comes into contact with the skin. The adhesive we've used is a special fast-acting one. In less than 20 seconds, the bond formed is strong enough to withstand a shearing force of about 250 newtons. There's nothing new about using adhesives to join things together. 3,500 years ago, the Egyptians were using glues made from natural materials such as animal bones and hides. The raw materials we use today are both natural and synthetic. These include natural rubbers, such as this, and various types of synthetic rubbers. We also use fillers and other additives to vary the properties of the adhesive, and in many cases, resins are used. These materials go to make a range of adhesives suitable for joining almost anything to anything. For example, an adhesive has been used on this brake shoe to join the asbestos lining to the metal backing plate. What advantage do you think an adhesive has over rivets? This artificial hand is made of an aluminium alloy. Here, an adhesive has been used to bond a strip of rubber to the aluminium. These are oil filters. They spend their life soaked in oil. This time it's the metal end plate that's been bonded to the filter paper. A cross-section through a helicopter rotor blade, where the skin is made up of several layers of an aluminium alloy. In this case, it has to be an adhesive that bonds them together. Other methods of joining would weaken the blade. How do adhesives work? Well, let's see how one behaves on a fabric, a porous material. See how the adhesive soaks in? If we turn the material over, you'll see the adhesive has penetrated through the fabric. We've deliberately used a thin adhesive to exaggerate the effect. Now we're coating a second piece of fabric with the same adhesive. If we put these two together, we can make a bond. We'll roll the two pieces to squeeze out any air. For a bond to develop, the adhesive must be left to dry out. Let's see what happens when we try pulling two similar pieces of fabric apart after the bond has had time to develop. We're doing this in a tensometer. Here we're peeling the two pieces apart. The fabric we've chosen is stronger than the dried adhesive. See how the adhesive is being stretched and torn? The bond is produced by the adhesive wrapping itself round the fibres of the fabric. The adhesive interlocks with the fibres, forming a mechanical key. This is called mechanical interlocking. But it's difficult to imagine how that could happen when joining two pieces of metal together. Metal, of course, isn't porous. Let's take a closer look at the bond. Here it is, magnified 500 times. Now you can see the adhesive hasn't penetrated into the surface of the metal. In this case, it's thought that a molecular interaction between the adhesive and the metal surface produces the bond. It's known as specific bonding. Mind you, the exact way in which an adhesive bonds a non-porous surface isn't yet completely understood. What is known is that a very strong bond can result. That took a force of 200,000 newtons to shear it. To make a successful bond, several factors must be considered. Here are two types of adhesive. Let's try the one on the left. On this material, a plastics material, the adhesive collects into globules. It doesn't stay spread out on the surface. We say it doesn't wet. Let's try the other one. This remains as a brushed out film. It doesn't collect into globules. In other words, it wets the surface of this material. Now, this is one of the factors necessary to produce an effective bond. But what about that first adhesive? It's designed for joining wood, so it should wet a wooden surface. And it does. Except in one place. Can you think of a reason for this? Part of the wing skin of an aeroplane. It's another aluminium alloy, and it has to be strengthened by stringers which are joined on by an adhesive. The surface must be prepared first before the adhesive can be applied. Another very important factor that affects the efficiency of the bond. The skin is immersed in a tank of very strong detergent solution. The contents of the tank are agitated to keep the solution moving over the surface of the skin. The detergent removes any grease that may be present. The skin is left in this solution for about 30 minutes. To get rid of the detergent, the wing must then be sprayed with high-pressure jets of water. Next, the surface is cleaned mechanically by blasting it with tiny abrasive particles. Because of the danger of inhaling these tiny particles, the operators wear face pads. In this process, the abrasive particles are fired at the metal by a sort of high-pressure air gun. After they've hit the target, they're drawn back into the system, cleaned and used again. The metal surface is then treated chemically, with care. It's connected to a supply of electricity, and then it's immersed in a tank of hot chromic acid. This treatment is designed to stop the material from corroding after it leaves the tank. It's called anodizing. This is the end of one of the stringers to be bonded to the wing skin. It's been through the same cleaning process. The adhesive is applied to the flanges of the stringers. Watch how it brushes out into a film. It wets the surface. Gloves are worn because this particular adhesive can cause dermatitis. The next stage is to cover the adhesive with a hardener, in this case a granular material. Without a hardener, this adhesive wouldn't work. It's a two-part adhesive. Now the stringer's ready. It's placed in a special assembly fixture along with all the other stringers. This fixture ensures that they're all in the right place. The metal skin, with masking tape over the areas where adhesive isn't wanted, is then lowered onto the stringers. It has to be carefully and accurately located. To complete the process, skin and stringers must be held together under pressure and heated to a temperature of about 150 degrees Celsius. This heat is an essential ingredient in producing the extremely strong bond necessary to withstand the vibrations in flight. In this cabinet, we're going to heat up 2 aluminium lap joints, each bonded with a different type of adhesive. Just to be awkward, we've labelled them B and A. For a heat source, we're using 4 infrared lamps. We measure the temperature on this meter. Now, both joints are under exactly the same shear stress, which remains constant throughout. 70 degrees centigrade or Celsius, and so far nothing seems to have happened. But now the adhesive in joint B is beginning to soften. It started at about 90 degrees Celsius. The adhesive in the other joint hasn't softened. Now, in the case of joint B, the adhesive was one of a type known as thermoplastic. That means they soften or become plastic when heated. The adhesive used to join A is one of a different type, known as thermosetting. These have to be heated before they'll create a strong bond. The wide variety of adhesives that are used today can broadly be divided into one of these 2 types. In this factory, badminton rackets are assembled using a thermosetting adhesive. The adhesive bonds a steel shaft to a T-piece made of an aluminium alloy. As it's a thermosetting adhesive, the joint must be heated to create a strong bond. Here, the racket travels up slowly between 2 infrared heaters. To join the wooden handles to the other end of the metal shaft, the same adhesive is used. The handle is pushed home and then put on one side, ready for heating. The adhesive used here is one based on a resin, an epoxy resin. It's supplied in 2 parts, which have to be mixed together in just the right proportions. The 2 parts of this adhesive are kept separately in 2 tanks. They must be kept apart until required for use. They're mixed automatically in a machine just above the nozzle. To check the strength of the epoxy joint, each racket is given a torque test. Here, a twisting force is applied to each end of the racket. The adhesive joining this brake lining to the metal shoe is a thermosetting one. Can you think why thermosetting and not thermoplastic? This polythene container is part of a breathing apparatus. An adhesive is used here to join it to the inside of a nylon bag. In this case, service conditions permit the use of a thermoplastic adhesive. A thermosetting one wouldn't do. Can you think why? The same adhesive is used to join a metal washer to the other side of the fabric. These are divers' dresses. They're made of a rubberized canvas material which is bonded together with a thermoplastic adhesive. The particular one being used here is called a contact or impact adhesive. It's a mixture of synthetic rubber, resin and solvent. An even film is spread over the surface to be bonded. It must then be left to dry. The same thing is done to the other surface being bonded. Here, the adhesive has already dried. Once both surfaces are dry, they're brought into contact and an immediate bond is formed. That's why it's called a contact adhesive. A roller is often used to improve the contact between the two films. In this case, the adhesive has to withstand fairly severe service conditions. Not only is a diving suit surrounded by water, it may also be subjected to oil and other fluids. Before deciding to use an adhesive, think about the conditions to which it will be subjected. You must also consider the materials you're joining. These might be concrete, rubber, wood, decorative laminate, chipboard, glass, or aluminium, to name but a few. Selecting the right adhesive can be difficult.
Development Lab, good afternoon.
So, when in doubt, ask one who knows. Adhesive manufacturers are always ready to give expert advice.
I see.
I want to stick metal to plastic.
And what metal and what plastics material, please?
It's aluminium to PVC.
I see. Will the aluminium be painted or plain?
The aluminium is unpainted.
I see. Right. Oh, and the PVC, will this be a flexible one or a rigid one?
No, it's a rigid PVC.
Yes, certainly. And what sort of conditions in service? I mean, what will it have to do in actual fact?
It's a plastic
Yes.
gear guard in a machine in one of our workshops.
I see. So there could be oil present as well, then.
Any idea which adhesive might be best? See if you can find out.
In 3 minutes, there's a programme from the series History 1917 to 1973.